Hello everyone, mic test, mic test. Hi Veron. Hi Eddie, Ruth. Okay, is my sound clear? Hi Veron. Okay, I guess it is. Okay, thank you Yiling and Yapning. Thanks Veron for the feedback. Why my video like cannot play? Okay, it doesn't work on my computer. Never mind, I still got my handphone. Okay, so thanks for joining me tonight. My name is Kevin Huang, the Curriculum Specialist at Heuristics. So tonight, I'll be talking about difference unchanged on the unit transfer method. So before I begin, let me talk to you about myself first. Okay, I started out teaching at Heuristics back in 2011, graduated from Nanyang Technological University with a degree in mathematics and economics. So I've been involved with the curriculum development and coaching primary school students in problem-solving heuristics in tackling challenging problems in maths, primary maths problems specifically. So about our company, Maths Heuristics, from our early beginnings as an enrichment center, we have evolved to become an industry influencer. So today we are a leading content provider, lauded in Singapore as an icon in the research of mathematics teaching methodologies. So at first we were set up to help students achieve breakthroughs in their study of mathematics, but for that to happen these days, students need all-around support. So what we do is that we offer a total learning experience with classes, guidebooks, mobile apps, web videos, and virtual classrooms. So, okay, I don't know why I keep on getting Facebook calls. With this, we can provide parents, educators, and students 24/7 support. Okay? So introducing the unit transfer method. Now it is a common practice for parents to jump online and seek help for particular maths problems through forums, social media, and other means. But you will receive many responses, some of them claiming their methods to be the fastest or the shortest in solving particular maths problems. But what many people do not realize is that when you tweak these questions, the same ideas and principles cannot be applied. So these scenario-based solutions are ineffective and encourage the child to memorize the solution. And that is why the child gets stumped when the question is tweaked. So instead, what I'm going to introduce is an effective problem-solving technique that is more universal and can cover across all types of word problems. So these are the unit transfer method books that I have. with me. So this one is for P4. This one is for P5 and P6. Okay? Then before I start, okay, for those of you who just joined me today and didn't view my Facebook Live last week, so here's a brief primer. I won't repeat everything. You need to understand the language of mathematics. So what many parents fail to realize is that it's not that the child does not understand the English in maths, but then they are being phrased in a different way. So the truth is that the English in maths is not very complicated, but in fact it's very simple. So as per the English language, there are a certain set of rules that you need, grammatical rules. So in the same manner, there is also a standard set of rules in the language of mathematics. So this is the first step to problem solving. Your child needs to interpret the language of mathematics across the topics of whole numbers, fractions, decimals, ratio, and percentages. Now let me illustrate how the unit transfer method uses the concepts of allocating units across all the various topics. But for now, because of lack of time, I will only show you whole numbers and percentages and how they are linked. Now when we say that Tom has half as many stickers as Mary, give me a while. Okay. This half can be changed into a fraction, and the denominator goes to Mary first, the numerator goes to Tom. In model representation for the P4s, this is how it would look like. Tom would have one block, and whatever Tom has, Mary would have 2 copies of that. So we call this 1 unit and 2 units. Now in the similar manner, this 50% can be converted into a fraction. By definition, this is 50 out of 100, and it simplifies down to half. Okay? So when you change this to half, it becomes the exact same problem as the one on top. The main idea here is to convert decimals and percentages into fractions first and allocate the units. So this 2 goes to Mary, this 1 goes to Tom, and then it simplifies down to the same exact problem. Okay, so if you have not viewed it, if you did not view last week's Facebook Live, view this video after this. If not, what I say will not make sense to you. Okay. Now let me just type it out first. Oh, hi Siva. Okay. All right. Now, how do we identify difference unchanged quantities? So there are 4 basic scenarios. Last week I covered single unchanged quantities. Today I'll be covering difference unchanged. Okay, for example, let's say that Ali has $40 and Ben has $100. And if both of them receives $50 from their father each, then Ali will have 90, Ben will have $150. However, if we are to compare the difference before and after, this will be 60, and so will this be 60. 100 minus 40 will give you 60. 150 minus 90 will give you 60. So how do we know such a case is a difference unchanged quantity problem? Look at the change rule. We see that we have the same number with the same signs. Then this means that the difference will remain unchanged. Okay? So for the P-force, to visualize this, this is how it happens. Now let's say Ali and Ben is here. Okay, so Ali got 40 here, and Ben has 100 over here. The difference before is 60. When you add the same number to them, you can see that this 60 doesn't change at all. Okay, so as a rule, when if you want to use models or you are forced to use models, when you have the same number being removed or being added in, put them on the left side together so that it is easier to see this. So that's the first part. The second part on forums I also see very often is that the age difference unchanged, the age difference between any two persons will always remain unchanged unless something happens to one of them. So the thing is, if Ali is 40 years old and Ben is 10 years old, 4 years later, both of them will have to age by 4 years. It cannot be that one of them is still trapped at 10 years old, correct? So with that in mind, Ali becomes 44, Ben becomes 14. Then when we look at the change rule, we see the same thing. Same number, same signs. The difference remains unchanged. Okay? Still remains at 30. This one remains at 30. Okay, hi Helena, Vidya, Derek, David. Okay. Hang on, let me refresh my stuff. It's a bit lagging. Okay, so this kind of age problems can appear as early as P4. Depending on your school, maybe it appears even at P3. So the main problem here is you need to understand that the age difference between any two parties remain unchanged. When you know that and you allocate the units, it can be solved rather easily using the unit transfer method. Okay, let me play the video for you. Okay, just to check, was there any sound just now? Yeah, no sound, no sound. Okay, never mind, I explained to you personally. Not sure what happened last week, it was working, but now, never mind, I am the backup plan. So in year 2009, Ali was 22 years old and 14 years older than Ahmad. So in which year will Ahmad be 2/9 as old as Ali? Okay, so this is the after result that we are after. This was before. So you got Ali and you got Ahmad. Before, change, and after. Okay, so in the year 2009, Ali is 22. The key thing here is that he is 14 years older than Ahmad. Ahmad is not 14 years old. So Ahmad must be 22 minus 14 to give you 8. Okay, so after a few years or a few years before that, they said which year. They did not say in the future or before that, in the past. They only ask you which year. So the change, you do not know what it is. Okay? Is it plus plus or minus minus? We do not know what it is. We leave it as a question mark first. Ahmad will be 2 out of 9 as old as Ali. So when we have allocated the units, this is what it will look like. So, since we got that, we look at the change rule, or we can also argue that the age difference will remain unchanged. They will experience the same number change in the same direction, either into the future or into the past. So with that reasoning, we can argue that there will be a same number with the same sign there. The difference now will be 14 here. The difference here will be 7 units. Okay? So, since difference remains unchanged, we say that these two are equal. We want to compare them. So 7 units is 14. 1 unit must now be 14 divided by 7 to give you 2. So once you got that, we need to find out either Ahmad or Ali's age when this 2 out of 9 proportion happens. So 2 units will be 2 copies of 2, that will give you 4. So in this case, the change means that you need to move back by 4 years for both of them. The question's objective is in which specific year. So since the present is 2009, okay, 8 minus 4 will give you 4. You need to move back by 4 years, so 2009 minus 4 will give you 5. Okay, 2005. Okay, so the answer here must be 2005. So did everybody get it? Can shift the whiteboard a bit to the right, please. Which whiteboard? Video looping. Okay. So is everybody still with me? Can't see the before. Okay, you try tilting your phone like that. Try tilting your phone like this. Okay. So is everybody okay? Yes, most of you got it. Okay, thank you, Jillian. Thank you, Vidya, Veron, Ding Lin. Okay, so the other 3 questions will be based on this idea. So this is what I've prepared just now, just to discuss with you in case you all are not sure. But anyway, I don't think I need this anymore. So let's move on to guided example 2 on whole numbers for primary 4. So when it deals with whole numbers, the model is very easy to draw because the numbers are still very friendly. So as the numbers grow bigger and less friendly, you will need a more universal way to deal with it. But for now, let me show you how to use the unit transfer method to solve this problem at P4. Now, Adrian has thrice as many stickers as Wilson. Convert this to 3 out of 1. 3 goes to Adrian, 1 goes to Wilson. Okay, each of them receives 15 stickers from their big brother. So there is an action, there is a change. Now Adrian has twice as many stickers as Wilson. Change this to 2 out of 1. 2 goes to Adrian, 1 goes to Wilson. So we observe that this is before, this is the change, and this is the after. How many stickers does each boy have now? Okay, let's draw out the BCA table. Adrian, Wilson, before, change, after. Okay. So Adrian has got 3 units at first, Wilson got 1 unit. Both of them receive 15 each. And now Adrian got 2 parts, while Wilson has 1 part. Okay, once we've done that, we can see that inside the change row, we have the same number with the same signs. Therefore, the difference remains unchanged and we can compare them. So at first, 3 minus 1 will give us 2 units. After that, 2 minus 1 will give us 1 part. So we say that these 2 are equal. We want to make them the same. So to make them the same, you'll hear me say this a lot in the future Facebook Lives. For this particular case, you need to cut them into their lowest common multiple. So in this case, between 1 and 2, their lowest common multiple is 2. To get this guy to 2, you need to multiply the after row, the entire after row, by 2 in order to maintain the ratio equivalence. Okay? So this becomes 2 and this becomes 4. So once we got this already, we can now say that from 3 units up to 4 units, there was a change of 1 unit. Okay? This 1 unit came about from the 15 stickers that each of them received. So once we know this, we ask to find how many stickers does each boy have now. So now means the after. Adrian would have 4 units. So 4 units is just 4 copies of 15. That give us 60. Then for Wilson, there will be 2 units, which is 2 copies of 15. Then that will be 30. So the final answer here for A would be 60, Wilson will be 30. Okay? So did you all get that? Okay. Yeah, okay, you're welcome, Lin. Tilted but still can't see. Okay. Right. Okay, yeah. Okay, if y'all got it, please give me some likes. If y'all didn't get it, give me some frowns. If you find that my way of presenting is very entertaining, give me some ha-has. Like this, this XD face. Okay? So, now that everyone is more or less attuned, let me move on to something slightly more difficult. Example 3 on percentages. So this will be for primary 5 or primary 6. Primary 5 has not learned it yet, but don't worry. Okay? Okay. Well, how come all of you give me the ha-has here? Okay, anyway. So let's move on to example 3 on percentages. Now a container contains some red and green marbles. At first, the number of red marbles was 30% that of the green marbles. So you see a percentage, change it to fraction first. This is 30 out of 100 by definition, and then that will be simplified down to 3 out of 10. Okay, change this to 3 out of 10 first. Then after adding 75 marbles of each color, so there's an action, there is a change. The number of red marbles becomes 80% that of the green marbles. So 80% in simplest form would be 80 out of 100, and that simplifies down to 4 out of 5. Okay. How many marbles of each color were there at first? Okay, so this was before anything happened. 3 goes to red, 10 goes to green. This is your change. Red to green becomes 4:5. 4 goes to red, 5 by right should come here, then come here, and 5 goes to green. How many marbles of each color were there at first? So you got red and you got green. Before, change, and after. Okay. So that was just interpreting the problem. Now we just write down what we have. This is 3, this is 10. As you can see from here, this before. You added 75 for both of them. Then your red to green is now 4 and 5. Okay, so after setting up the problem, what do you do next? What do you do next? Okay. Difference. Okay, why difference? Yap Ying, why difference? Change to common factors. Okay, Joycelyn, that one is later part. Difference of each scenario. Make difference the same. Okay, why can you make difference the same? Use units and parts. Okay, Sheila, that one maybe next time. Okay, difference called, okay, why can you compare the difference? You need to know the reason first. If you understand the reason, you can apply it to other problems. The reason is you have the same number with the same sign. That's why the difference remains unchanged. Okay, once the difference is unchanged, this will be 7, this will be 1. We say that these two are equal, you want to make them the same. So, between 1 and 7, their lowest common multiple is 7. Therefore, we multiply this by 7. Then this one becomes 35. This one becomes 28. Okay? So once we got that, we can say that before that I got 3 units. Then later I increased to 28 units. There was a change of 25 units. Correct? Now this 25 units came from the 75 marbles that were added. So 1 unit will be 75 divided by 25. Okay, that will give you 3. Okay, Yap Ming, I just saw your comment just now. Why is this the case? Now imagine if you have 25 blocks. 1, 2, 25 of them, and they give you a total of 75. How do you find one of these blocks? You have to take the 75 and divide it by 25. Okay? So how many marbles of each color were there at first? You want to find out 3 units and 10 units. So for the red, that would simply be 3 units, 3 copies of 3. That will be 9. The next one will be 10 units. There will be 10 copies of 3, so that will be 30. Therefore, your final answer here would be, for red is 9, for green is 30. Okay? Did everyone get it? Added the same marbles. Yep. See that? You got it? Well, that is the standard, right? It is standard because I'm doing difference unchanged here today. But for other different problems, it may not be the case. You have to really check the change rule first. Okay, so can I proceed further? Well, now my handphone's jialat. Okay, so I think I can. Yes, okay, good in the end. Okay, no need this. Okay, so here is a higher order thinking skills problem. This one, if you downloaded the notes, you will see that this is considered a tweaked problem. Okay, now Harry had $400 less than Lyndon at first. So this was before anything happened. When they both spent their money to buy the same wallet, this is the change, because it's an action. Then the ratio of Lyndon's money to Harry's money became 3:1. Oh, my phone died already. But don't worry, I still have my laptop here. Okay, given that the total amount of money they had left is 2.5 times the cost of the wallet, find the cost of the wallet. So 2.5 is 2 wholes and 5 tenths. Okay, then we change it to improper fraction. That will be 25 out of 10. And this becomes, this simplifies down to 5 out of 2. Okay, I'll explain why I do this in a while. Okay, and this statement, the total amount of money they had left, is referring to the after. True? Okay, so once we got that, we can draw out the BCA table first and compare between Harry and Lyndon. Okay? So before you do not know exactly what they have, you can write it as 1U plus 400, 1 and 1 unit, but I don't recommend that for the time being. So if both of them spent their money to buy the same wallet, that means both of them would have experienced, would be spending the same amount of money. Okay? And both are spending. So the ratio now becomes 3:1. Now bear in mind that this is a proportion, so we use units here. Okay, so the next thing is that this $400 less is actually also referring to the difference. It's just that they don't tell it to you specifically, they don't tell it to you explicitly. But this difference is 400. Okay, then because you have the same number and the same signs in both of them, they are experiencing that same change, and therefore the difference remains unchanged between them. So once the difference remains unchanged between them, we can compare these 2 units and 4 units. Okay, so if 2 units is $400, then 1 unit will be 400 divided by 2 to give you 200. The total amount of money they have left will be 4 units, correct? So 4 units must be 4 copies of 200. That will give you 800 over here. Correct? And now we look at this last part here. Okay, the total amount of money they had left is 5. The cost of the wallet is 2. Okay, for students who are very fast, they can just say that the cost of the wallet is 800 divided by 2.5. Why do you need to go through all this? The reason is the concept of rates for P5 will be taught later on in the year. So if they are not too sure about this, this is how I would present for them at the start of the year. When they get better, of course, they can use faster methods. Okay, total left can be broken down into 5 blocks. The wallet would have 2 blocks. Okay, then this whole thing, this entire leftover is 800. To find the cost of the wallet, you will now need to take 800, divide it by 5. 5 of these blocks to get one of the blocks value. So this will be 160. Now thereafter, you want to find the cost of the wallet first. The cost of the wallet will simply be 2 copies of 160. So that will be 320. So the final answer here is $320. Okay, did everyone get it? Yes, Sheila, 2 units is 400. Yes, yes, yes. Okay, if you got it, give yourself some likes. If you, what you call? If you don't understand, give me some frowns. Okay, got it, Vidya. Okay. So the main idea here is that this less than is also referring to the difference. Okay, this is the part that they don't tell you explicitly. Right, so, got it, huh? Okay, now I come to the end of my presentation. Yep. So if you'd like to learn more about this unit transfer method, we have a parents webinar that can help you to understand how to tackle these challenging problems across the topics of whole numbers, fractions, decimals, ratios, and percentages. The link is here. Let me type it out real quick. Calculator, and I don't even need to use it. If I cannot type here. Jialat. Oops. Wait, let me type out real quick. Okay, sorry for the technical issues. My phone ran out of battery already, so I can't type it out on my phone either. And there's a lot of people messaging me on Facebook also, so I don't want the privacy to be compromised. Okay, so this is the link to the UTM Parents webinar. And also, to get the complete mastery of the unit transfer method using our integrated learning platform. It comprises of 10 lessons spread out across 10 chapters. So the link is over here. If you want to learn more, you can go and read up about it. Okay, it comprises of the unit transfer method guidebook, this one here, available for P4 and P4 and P5 and or 6. Then it also comprises of web teaching videos, the Maths Heuristics mobile apps, virtual classroom, and the Facebook group. Okay, so you all can learn more about it. If you all have any questions, you all can give it to me now. I will entertain you. You're welcome, Sherlyn. Why is it 800 divided by 5? Okay, Veron, the thing is, if you look back at this, there's 5 blocks here, correct? Your total amount of money left is $800, and it is also 5 blocks. Alright, okay, you're welcome, Vidya, Sheila, Joycelyn. Okay, see you, Derek. Okay. Now the thing is, I can look at your comment, but I cannot type in. Where can we buy the guidebook? Okay, Joycelyn, you can purchase it from this link here, go.gl 6TG1FM. But take note that the alphabets are case sensitive. Okay, you're welcome, Cecilia. Welcome, David. Okay, you're welcome, Niak Wing. Okay, any other questions? So yep, now my setup is quite zai. First I got my tablet here, then I got one backup laptop here, and then I got my phone, and then I also have a tablet here. Okay, then let me try using the tablet to type in the link. Yeah, where is it? Okay, you're welcome, Eddie. Welcome, Ruth. Okay, yeah. Bye, Sheila. Okay. Wait, okay, bye, Jocelyn. Okay. You're welcome, Kira. I'm happy to hear that. There'll be more in the next coming weeks. There'll be 3 more sessions on this. The next one will be next Wednesday. I'll be covering on Total Unchanged, same time at 8 p.m. Okay, so do join me if you're free. Thanks for tuning in, Kira. Okay. Yeah, anyway, here are some of the common questions that parents have asked me during last week's session. The bar model is still widely being used and not a heuristic in school. So how to make out what you shared using bar model? Okay, so the thing to this is the MOE has advocated 11 heuristics in primary maths. Model drawing is only one of them. Okay, then the unit transfer method consists of a combination of 5 out of the 11 heuristics. Then there will be questions that cannot be easily solved using models. Probably if you draw enough blocks, you will get it eventually. But these problems, they require specific heuristics like systematic listing, guess and check, making supposition, looking for patterns, and so on. So in model drawing, the child draws units and solve the problem visually, whereas in the unit transfer method, the child uses the numerical values. Now both are similar in idea of using the concept of ratio. Now as every child has a different learning profile, it is important to expose them to different approaches so as for them to have the flexibility to choose the methods that they are comfortable with. But more importantly, they should use the method that they can get the question consistently correct. Okay? So the whole idea here is not about looking for the fastest way. I mean, I know how to do it, but I won't do it because I find it very case specific. So that's not what I want to impart. I want to impart the thought process behind solving the problems. Okay? So I guess if there's no other questions, I'll be logging off now. Thanks for having me. So this is Kevin from Maths Heuristics, signing off. See you soon.